Today, we're going to introduce one of the most important skills in coding development, building a project. Let's say you've learnt coding in university, you've done a lot of LeetCode practical coding, and you've even watched a bunch of YouTube tutorials on how to code, but you still feel that you can't build a project. Why is that? Coding is not just coding. Building a project requires a lot of skills that are not related to coding itself. The most important one is the thinking skill. Everyone knows this, but not everyone knows how to think. In this video, we'll give you all these skills except coding itself. Once you have these skills, you can easily build a private cloud drive with AI's assistance, even if you just started learning coding this week. Our goal is to compress the whole university computer science course into 6-month sessions for you. Once you finish all these sessions, you'll not only have all the skills you should have, but also the skills to be a full-stack developer with AI's assistance, which normally takes years. To achieve this, you need to complete all the assignments and homework in our video as required, not just watch the video. Before you do the assignments and homework, we'll give you all the concepts and knowledge you need to know in this video. And once you watch this video, you'll see how we use thinking skills step by step to introduce the knowledge and concepts to you. Let's talk about how to start a new project. To start a new project, you have several options. Number 1, write code from scratch. Number 2, find and modify a similar open source project. Number 3, use a third-party library or package. Number 4, choose a framework or boilerplate to start. And number 5, to utilize low-code or no-code platforms. Let's explore the best approach. In universities, you're often taught to write code entirely from scratch. While it's possible to build projects this way, it can take a lot of time and effort. In the real world of development, things are different. Most of the time, developers don't start a project from scratch. When starting a project, a developer often researches and finds a similar open source project to use as a base. Open source means the code is freely available for anyone to view, modify, and use in their own projects. For example, we've learned that Linux is open source, allowing you to view, modify, and even use its code to your advantage. If you want to build a private cloud drive, you can search GitHub or Google for similar open source projects. Once you research and explore, you might find a project that's open source and meets your needs. All you have to do is modify it slightly, saving both time and effort. This approach is often described as standing on the shoulders of giants. By building on existing code, you don't need to write everything from scratch, or reinvent the wheel, so to speak. However, sometimes it's hard to find an open source project that exactly matches your needs. In those cases, you can search for libraries or packages that might help. Let's learn about them next. A library or package is a collection of reusable code that provides specific functionality. Instead of writing code from scratch, it's often more efficient to find a third-party library or package for the core features that we need. For example, if we're working on a video-related project, we might choose the FFmpeg library, or if we're working on a files or network traffic encryption project, we could use OpenSSL library. Libraries and packages are essentially the same concept, but the terms can vary depending on the programming language. You can also use a framework to build your project. Frameworks are pre-built structures that help developers save time and effort. Some developers refer to frameworks as boilerplates, which suggests that everything is ready for you to start building your project without needing to set anything up. A popular website framework or boilerplate is Next.js. It comes with built-in functionality, including all the necessary third-party libraries and packages for both the front end and back end. Frameworks often select the best libraries or packages for you, so you don't have to worry about choosing them yourself. If you're unsure which framework to use, you can always ask an AI or search online for recommendations. Sometimes it's easier to use pre-built no-code or low-code software or platforms for a project, such as for a CMS, content management system, CRM, customer relationship management, or online community, etc. Instead of coding everything from scratch, You can use these platforms with cloud hosting services like AWS to set up your systems and build projects with minimal coding. You can also use SaaS, software as a service platforms, which have everything pre-installed in the cloud. Just sign up, log in, and tailor the system to your needs. You can use any of these approaches, but before making a final decision, check if the project you find on GitHub has good documentation and even sample code. Build and test it to ensure it works in your environment without errors. We've learned that having a working instance is crucial. It allows you to add your own code and, if necessary, roll back your changes if you encounter errors that are hard to fix. You can then add your code gradually, testing along the way. Before starting a new project, it's a good idea to search for similar projects on GitHub, which you can visit at github.com. Think of GitHub as a huge collection of open source projects that you can use, modify, and build upon. Simply search for a project using keywords relating to what you're looking to create. When you find an open source project, it's important to check the license, especially if you're planning to use it for commercial purposes. If it's a personal use project, the license doesn't matter as much. But for commercial use, you need to ensure it's free or within budget for any costs. For most commercial projects, you want to look for licenses like MIT, Apache, or BSD. These allow you to use, modify, and even sell the software for free with closed source code. However, licenses like GPL require you to make your project open source if you use their code, which might not be suitable for commercial work. To find a project's license, check for the license file in the repository or look in the README file, which often includes licensing details. You can also check the About section on the right side of the main page, where GitHub displays the license information. One important thing to know: if there's no license file in a project, you can't use it in a commercial project, as the author retains all copyright by default on GitHub. Besides licensing, it's also important to check the popularity of the project. Look at the number of forks, stars, and contributors. A project with a lot of forks and stars is likely to be stable and widely used. Additionally, check the latest commit dates. If the project has recent updates, it's actively maintained. But even older stable projects can be useful if they don't have major issues. By checking the license, popularity, and maintenance activity, you can choose the best open source project for your needs. Let's dive into what GitHub really is. GitHub serves multiple purposes. It's an open source project hub where developers share and collaborate on projects. It's a collaboration platform that makes working on code with others easy and efficient. It's a repository hosting service where you can store and manage your code. It's also a social network for developers where you can showcase your work and connect with others. Instead of passively watching tutorial videos endlessly, focus on building a project on GitHub that interests you. As you work on your own project, you will only be learning the necessary skills to continue moving forward. This approach keeps your learning practical and focused. Coding is not just about knowing syntax or concepts. It's about problem solving, research, and critical thinking. Your coding skills will exponentially improve when you apply them to a real project. Your GitHub profile can act as a portfolio, showcasing your skills to potential employers. A project with many forks and stars on GitHub is often more valuable than a traditional resume, as it directly shows your work and impact in the developer community. Employers can easily see your effort in the project, which is the most important value your employer may care about. If you're studying in university or looking for a job, take the time to build up your GitHub profile. A strong profile can help you stand out and make it easier to secure a job. In each of our videos, we have a real project assignment. You can host these projects in your GitHub account to show all the skills you have. Sometimes people get confused between Git and GitHub. We've already learnt what GitHub is, so now let's explore what Git is all about. Imagine you're a contract manager in a business. You have a contract template that you use for different customers. For one customer, you create a folder called Customer A. Before finalizing and signing the contract with this customer, there are several rounds of negotiations and meetings. After each round, you create a new contract version, saving them in the same folder with different file names as version 1, version 2, version 3, and so on. At the same time, you're also working with another customer, customer B, and you manage their contract in a separate folder in the same way. This concept is very similar to how Git works. Think of your code in a project as the contract. When you create a new version of the contract or code, this is called a commit. When you create a separate folder to manage the contract for a different customer, this is like creating a branch in Git, which helps you manage different versions of your code for different features or experiments. The major difference between a Git commit and a traditional file backup is how the changes are stored. In a typical file backup, each time you save a new version, the entire file is copied and stored. This takes up more space and can become inefficient as the number of versions grows. In contrast, Git commits only save the differences, or deltas, between the current version and the previous version. Instead of copying the entire file, Git tracks the specific changes made, whether it's an added line of code or a deleted section. This makes Git far more efficient for managing version history, as it minimizes storage space and allows for easy tracking of incremental changes. Just like using different folders to manage contracts for different customers, Git introduces the concept of branching. Branches allow you to work on new features or fixes in isolation without affecting the stable version of your project in another branch. Typically, the stable version is called the main or master branch, while ongoing development happens in the develop branch. You can also create separate branches for new features, enhancements, or bug fixes. In Git, instead of using numbers or version labels, each commit is identified by a UUID, or a universally unique identifier. So what exactly is a UUID, and why does Git need it? Git is designed for distributed collaboration, where developers can work from anywhere in the world on different computers. To ensure that each commit is uniquely identifiable across all systems, Git assigns a UUID to each commit. A UUID is a 128-bit identifier designed to be globally unique. No two UUIDs will ever be the same, no matter when or where they're created, even on different devices or networks. This ensures that every commit is uniquely recorded without duplication. UUIDs are commonly used as unique identifiers in distributed systems where the identifier doesn't need to be human readable, but is crucial for the system to distinguish between objects like database records or cloud file names. They're especially useful in scenarios where uniqueness is required, but human interaction is minimal. In Git, every commit is a snapshot of the changes made since the last update. But instead of storing entire files, Git only saves the difference between commits. This makes collaboration and version tracking more efficient. When collaborating on a project, this concept is critical. It allows us to see exactly what has been updated before making a commit and let us work seamlessly with others. Sometimes we need to create backups of these differences or even apply them to a different branch or project. This process is known as creating and applying patches. Let's explore some useful Git and Linux shell commands that we can use in our daily development workflow. First, let's talk about comparing changes. The Git Diff command is your main tool for seeing the differences between two versions of a project or file. It helps you easily spot what has been added, removed, or changed, so you can track how your project evolves. By using the command git diff version 1, version 2, you can compare two specific commits and see exactly what changes were made. This helps you understand how your project has evolved over time, ensuring that no changes go unnoticed. For simpler file comparisons, especially outside of Git, you can use the Linux shell command diff file1 file2. This allows you to compare two individual files, showing the differences between them. It's a quick and easy way to spot changes between two versions of the same file. For a more visual approach, the vim diff file1 file2 command opens both files side by side in Vim, highlighting the difference. This is especially useful for manual file comparisons when you want to see everything in one place. It makes it easier to manually review and edit files. Now, let's talk about patch files. With shell command git diff mychanges.patch, to create a patch, you can generate a patch file that stores the differences between your files. These patches are great for transferring changes to another branch or project. To apply these changes, you simply use the git apply patch file command. Patches are incredibly useful when you need to ensure consistency across different environments or teams. When you find an open source project on GitHub, you can create your own version by forking it. Forking makes a copy of the project under your own GitHub account, where you're free to make changes. Even though it's your own version, it's still connected to the original project. So if the original gets updated, you can pull those updates into your fork. If you make improvements or fixes, you can submit those changes back to the original project through a pull request. A pull request is a term used in Git when you want someone to review and merge your code changes into their repository. It's called a pull request because you're essentially requesting that the repository owner pull your changes into their project. One important thing to know, when you fork a public repository on GitHub, your forked version will also be public, and you can't make it private. If you want to work on a public GitHub project but keep your changes private, a common practice in commercial projects, you can follow these steps. First, clone the project directly to your local machine without forking it by using the command git clone public repository URL. Then create a private GitHub repository in your own GitHub account. After that, add your private GitHub repository as a remote to the clone project by running git remote add your private repository URL. Here, the label private refers to your private remote, but you can give it any name you prefer. Finally, push your clone project to your private GitHub repository's main branch with this command, git push private main force. Be careful to use the force option, but it's safe in this scenario. To verify the setup, use the command git remote -v. You should see two remotes listed, origin and private. Please note that origin is just a default label for the public remote repository when you make the clone. It can be renamed to anything else, but it's commonly used to track the original source. This setup allows you to pull updates from the public repository while keeping your own changes private. Here's a question for you guys. How can you create a pull request from your private repository to the public repository which you cloned? Think about it yourself for now. There will be an AI prompt in the assignment for this later on. Please remember to make contributions to the project you cloned once you find any bugs or make improvements, so you can benefit each other in the open source community, even if you're working on a private repository. When we clone a GitHub repository with the command git clone git URL, actually the command is git clone SSH URL. You can see it is using the SSH protocol, which is why you need to set up your SSH key as the authentication before you can clone the GitHub repository. SSH, which stands for Secure Shell, is commonly used to access remote servers. Before SSH, we used Telnet, which transmitted data in plain text, making it less secure. You've probably heard of HTTP or HTTPS. Telnet is similar to HTTP, while SSH is comparable to HTTPS. Just like HTTPS is used for securely accessing web content, SSH is used for securely accessing a remote server's shell. Both HTTPS and SSH rely on the same encryption technologies, asymmetric encryption for initial authentication and symmetric encryption for faster, ongoing communication. Symmetric encryption is easier to understand. It's like using a password to encrypt a file. Anyone who has the same password can decrypt the file. A well-known algorithm for symmetric encryption is AES. However, passwords are private, and people don't want to share them for security reasons. This is where asymmetric encryption comes in. Asymmetric encryption uses a pair of cryptographic keys, a public key and a private key. The public key is safe to share and is what you add to platforms like GitHub or your cloud server for authentication. The private key, on the other hand, must remain confidential and securely stored on your local machine. It acts as your digital signature and should never be shared. You can generate your public and private keys using shell commands like SSH keygen. There are different algorithms available for SSH keys, with RSA being the traditional choice. However, ED 25519 is now preferred because it provides stronger encryption and better efficiency. Both RSA and ED 25519 use asymmetric encryption, meaning one key, the public key, locks the data, while the other key, the private key, unlocks it. Data encrypted by the public key can be decrypted by the private key, and vice versa. However, asymmetric encryption and decryption are much slower, so we typically use it only for the handshake to confirm each other's identity. After that, both HTTPS and SSH generate an AES key for encryption and decryption during data transmission, often referred to as the master key. This way, we can ensure that we have connected to the correct server we want to access or visit, and then use fast encryption and decryption for the subsequent data traffic. OpenSSL is a widely used library for both asymmetric and symmetric encryption. We can use it directly through the command line in the shell or integrate it as a library in our code. Git is designed to manage source code versions, but we often need to store binary files, such as images and videos. While Git can handle these files, it's not considered the best practice. Typically, we use cloud storage services like Amazon AWS S3 Simple Storage Service to store such files. AWS S3 uses the concept of a bucket. You can think of a bucket as a remote folder or hard drive in the cloud. Each S3 bucket must have a globally unique name, since anyone can create a bucket for their use. Just like how files on your local drive have names, in S3, each file is identified by a key. The key must be unique within the bucket, and using a UUID is a good way to ensure uniqueness. When using S3 to store files, it's sometimes helpful to mimic your local file structure. You can do this by using a key like assets/images/png, which simulates a folder hierarchy in the cloud. In essence, AWS S3 is a distributed key/value storage system. Along with storing binary files, you can also store JSON files, effectively using it as a NoSQL database. What is JSON and what is a NoSQL database? These are simple but important concepts, and you can Google or ask an AI for more information. We'll cover them in more detail in future videos. Do you currently use cloud storage services like Google Drive, iCloud, or Microsoft OneDrive? Have you ever had privacy concerns about storing your data on these public cloud platforms? In this video's assignment, we'll let you build your own private cloud drive using AWS S3 with the help of AI in Python or Node.js. With just a few simple steps, you can monitor any file changes in a local folder and automatically sync those changes to AWS S3, giving you complete control over your cloud storage. AWS provides a free usage tier, so if you don't have an AWS account yet, you can sign up for a free account. Once your account is set up, please create a free EC2 instance for SSH Remote Access Practice and set up an S3 bucket for your private cloud drive application. An EC2 instance is a VPS, Virtual Private Server, just like a virtual machine in the cloud. In our next videos, you'll need to use AWS to finish some assignments, so be prepared to use it. In the description of this video, you'll find the link to join our Discord server, where you can access the assignments and get support from our AI assistant, Bytemate. After joining, you can ask Bytemate for the free assignment associated with this video. This assignment will guide you through practical shell commands, including setting up Git, generating SSH keys for secure authentication, and practicing OpenSSL AES encryption to protect your data. In the assignment, you'll be asked to build a real project, your private cloud drive with ByteBoss AI Agent, just like Dropbox or Google Drive, which you can use as your own private cloud storage without any privacy concerns. Even if you're just starting to learn coding, you can build a real project now with AI's help. This is how we learn with AI today, enabling you to create practical, impactful solutions right from the start. These exercises and hands-on projects are designed to deepen your understanding of Git, SSH, AES encryption, and cloud storage, ensuring that you not only grasp the concepts, but also can apply them in real-world scenarios. If you found this video helpful, don't forget to like, subscribe to the channel, and click the notification bell so you won't miss the upcoming sessions where we dive deeper into AI-assisted development and coding. See you in the next video.